Good evening, everyone, and welcome to this week's edition of the Caroline Weather Discussion. I'm James Brierton. Our faithful leader, Scotty, has the night off for, if I recall correctly, his birthday. So we sent him out a happy birthday, and he will be back again with us next week. I see our panel is here, our guest is here, so we're going to get started in just a moment. But as always, we like to go around the group and find out what's happening in, I guess as Al Roker would say, their neck of the woods. So we will start with our friend Shay in Charleston. Good evening, Shay.
Hi, James. How are you?
Good. How are you?
Very good. Very good. Yeah, weather pattern here still a little bit unsettled. We're having some low pressures and cold fronts moving through the area. Subtropical jets a little bit to our north, so we're in the moist sector down below it. And I see surface temperatures are holding right around 74 to 75 degrees Fahrenheit. So we're just sort of stuck in this kind of a wet pattern right now and hope to break through that by this weekend. So just kind of watching some low pressures offshore. Nothing tropical in nature, but as we start to slide towards hurricane season, which is what this show is going to be about on June the 1st for the Atlantic Basin, we always want to watch things that appear close to the coastline, tail end of cold fronts, and especially watching that Gulf moisture as it trails up into the southeast region. Back to you.
Thanks. Yeah, we'll be talking about that forecast and a little bit about the tropics in just a moment. And if you were with us last week, you would know that it's always good to be prepared, especially since we've had some relatively quiet seasons. So we'll get into that discussion in just a moment. But let's go up to Philadelphia, where, at least for the moment, his internet appears to be working. Peter said he was having some internet problems.
Yes, thank you, Comcast. Anyway, yeah, it's been not so bad here the last few days. A little cloudy, a little sunny, mixed bag of everything. But next 2 days look pretty good. We're going back up to the 70s, so I can whip out the plaid short-sleeve shirts again. Looking good. And then Saturday's going to be a little cloudy and damp, but next week looks better. So kind of up and down spring weather the last few weeks. But hopefully there's light at the end of the tunnel. So.
But Peter, the question is, if it ever gets warm enough, will you ever actually put on the Fox 29 T-shirt that's on the couch behind you?
That's a good question. I don't know. It's collecting dust right now, and it's been that way for the last probably 12 months or so. So I don't know.
It just looks like a pile of clean laundry.
Yeah. I mean, I might surprise you one day. You never know.
As opposed to the pile of dirty laundry that I have on my couch. So.
Well, that's good. Nobody could see it, so it's all right.
And we'll welcome back this week Kit. Kit, are you still at school? Are you still on the north side of Charlotte?
I'm actually back home in good old Belmont.
Oh, all right. And how are things then on the west side of town?
Do what? Sorry, you broke out there a little bit.
I said, how are things then on the west side of town?
Things are sort of back at the last bit of the front coming through. I'm going to share a radar thing that I've got up here. Just a few clouds over the Belmont and Gaston County region. Oh, zoomed in a little too close there. But we can see some clouds from the GOES satellites moving over Gaston County with this bit of rain on the NCSC line. But for the most part, it's pretty nice. 70 degrees is right where I like it for this time of year. So it's looking pretty good. I think I've ended my screen share there, yeah.
Yes, and I just canceled it as well.
Might get a little bit of rain here in the next few hours, but for the most part, it's going to be pretty nice through the evening, I think. I like a little evening rain.
That's exactly what I've been looking for. We've got clear skies here on the south side of Charlotte near Pineville, cloudy and rainy for a bit of today, as it has been for much of the week. But hey, the sun seems to be popping out now, which is nice. But we'll wait to see if what you had from the mountains and through the foothills survives as it rolls a little bit closer to the metro. We go from Charlotte to Charlottesville. Friend of the show, David Reese, is with us this week and sitting in on our panel. So good evening to you, David.
Good evening, guys. How are you doing? And you guys keep speaking of the sun. What is the sun you guys keep speaking of?
It's a big fireball in the sky. It's a rare astrological event.
Is that what it is? I mean, my goodness. We've only had, what, 3 dry days so far this month?
Are you kind of locked into that same system that I've been seeing the Capital Weather Group talking about with kind of like the prolonged rain period?
Oh, yeah. I mean, we had a stretch there of 11 straight days of rain. Unfortunately, we had a trace on like 2 or 3 of the other days. Otherwise, we'd have rain for pretty much from the end of April all the way up until about 3 days ago. So it's been remarkable. We picked up about 5 to 6.5 inches of rain. I'm the most hated person in Charlottesville right now because I keep the clouds and rain around. Hopefully we'll break out of this tomorrow and Friday morning, but unfortunately more rain is possible on Friday night and Saturday. And of course, UVA, University of Virginia, they have final exercises. That's what they call graduation here. They do that on the lawn.
Sounds scary.
It does, doesn't it? A final exercise, and they do it out in the lawn, so you think they're actually going to be exercising. Anyway, they do it in the lawn in front of the rotunda, so it's outside. So they might get a little wet Saturday morning, especially if some of the computer models that give us 1 to 2 inches Saturday morning are correct.
It'll be interesting to see on Thursday when the new drought monitor comes out if we can get rid of those little patches of yellow that remain there for abnormally dry, because it would seem, at least in the recent days, that we've had plenty of rain to go around.
Mm-hmm.
Yeah, David, I thought I saw you put something on Twitter the other day. It looked like a grand epiphany or something, with a ray of sun coming through the clouds for an hour, maybe.
I mean, it's been remarkable. We saw some sun Saturday, Sunday, and Monday, but pretty much every other day so far this month it has been cloudy, rainy, gray, dreary. I'm running out of adjectives to say it's going to rain and cloud covered tomorrow. So, you guys know of any? Let me know.
We'll do. Well, about 10 minutes past the hour now. We want to get right into our big conversation of the night, is discussing the 2016 hurricane season, but I want to let all of our live viewers know that if you have a question, and many of you did last week, so we hope they will come again, you can get in touch with us on social media. The easiest of ways is probably on Twitter, at Carolina Weather Group, but we're also on Facebook and, of course, YouTube and Google Plus here as well. Levi, how's the weather up in your neck of the woods?
Well, I guess down relative to you guys. I'm in Florida. It's been pretty nice. Got some rain today and some thunder, and I'm always down for thunder, so that was pretty nice.
Well, I'm glad we're able to have you on this week, and I'm glad I'm getting a chance to finally talk with you, because I wasn't able to make the show that you were with us not too long ago. So thank you so much for coming back, and I'm sure the panelists have lots of questions here as we make our way through May. But for folks who maybe aren't familiar with your site, I know a lot of people in the weather industry are, but folks who aren't familiar with Tropical Tidbits, do you have an elevator pitch you often give to explain it to people?
Sure. Well, it started off as just a host for my blogs that I used to write over at the Weather Underground website. I moved my blogs over to my personal website, and that's all it was for a while. And then I decided to start plotting data, because data that we use all the time and talk about in forecasting, I wanted to get my hands on it myself. I like being in control of data when I can. So I started plotting things, coding, starting running things live on my server, and it's just kind of grown since then to be a web page for numerical modeling, for tropical information on current TCs, and all that fun stuff. So it's just a place to host my personal projects and my blogs.
And I see Shay is currently looking at it right now, so we'll go ahead and put the screen share up from Shay's monitor, and there's a lot of data on here, and I know that's one of the things a lot of people come to your site for. Where do you get all this data from?
It's all free from the various modeling centers. Much of it comes straight from NOAA. Some comes from Canada and some from the Europeans. But NOAA provides a lot of data for free. It's a great resource.
How did you decide that tropics was the thing that you were most interested in?
Somewhere along the way growing up, I grew up in Alaska, so it is a little strange, but I saw enough hurricanes on TV, I believe, that I just started getting really interested. I really remember 2003 is the year when I started really tracking things. Hurricane Isabel really piqued my interest in a big way, and ever since then I've been tracking them nonstop.
Yeah, you would think, I guess, just kind of off the cuff, a guy from Alaska is probably going to like cold weather and snow, but you're in Florida now, so do you have a hatred towards cold weather and snow, or you just kind of came to like the tropics more?
Oh no, I think I miss it now. This is my second summer with 100-degree heat in Tallahassee. I've had more than enough of that at this point.
And David is laughing because David, you're from Sarasota.
Yes, I grew up in Sarasota. I also went to Florida State undergrad there from 2006 to 2010. Spent a couple summers there during summer school, and I know exactly what you're going through right now.
Yeah.
David's got some rain, though. If you want to go up to Virginia, he could, you guys should swap or something.
Rain and 60.
I'd take that.
Shay, I want to start with you because you're kind of our resident expert when it comes to a lot of coastal things. You've got an eye on a lot of this. So, Shay, I'm really curious to know what's top of your mind tonight as we kind of gear up for this hurricane season. And I know you also just watched the unofficial Tropical Tidbits hurricane preview come out. So, Shay, what's on your mind?
What's on my mind is our transition from El Nino to La Nina and what that's going to mean for the Atlantic Basin. Also the Pacific coast as well, but we're always concerned about our coastlines and being 10 and 11 years without a major storm landfall in the United States. That's also going to come into play as a major concern because I feel that, and many feel that people have become a little bit comfortable in their surroundings along the coast. So I think that when we do have a show in a couple of weeks coming out, I think June 8th actually, where we're going to be talking about that very thing. So you know, whether or not we're going to have some homegrown systems, as Levi will talk about and what he did in his video, where we're going to have fast developing systems near the coastline to affect those areas of the coastline is going to be a major concern. But our El Nino values right now, we're just the Nino 3.4, which is the only index region of El Nino, or the ENSO diagnostic area, is down to below 0.5 now. So it's actually, I took a dip down near 0 at one point, and let me go ahead and share a screen on this. Let me know when you can see it.
I think it's coming up right now.
Yep. Okay. So that's this is right off of Levi's site for the CDAS Nino 4 index. Can you see that?
Yes, we can see it.
Okay. So you can see these temperatures, these sea surface temperatures have dipped down. In Nino 4 region, 3.4 is where this is where the ONI index values come from for gauging whether or not it's El Nino or La Nina. So we gauge that on a +5 or -5 value over or above normal before we get into neutral. So it looks like the 3.4 region is in the neutral phase right now, although it hasn't been listed as that. Nino 3, you can see the numbers steadily falling down, so the sea surface temperatures are cooling overall in this area. The depth animation for the thermocline, and you can see right here the equatorial temperature. You see these warmer sea surface temperatures are receding back to the west. So this thermocline is lifting, the cold water upwelling is occurring, and it's starting to cool these sea surface temperatures at the top as these easterly trades relax somewhat. Our ONI index value, the latest one that we have on file from the ENSO diagnostic, is 1.6, which is about 1.1 over into the El Nino values. So once that gets to 0.5 and below, that's when we get into the neutral phase on that, and that's the February, March, April for this year. Once we get into the March, April, May and see what they have to say about that, we'll probably find that number down close to 0.5. Probabilistic outlook, we're looking at about a 50, actually went up from 52 to 60, looks like about 64, 65% from June, July, August. So here's the La Nina values looking much stronger than they did a couple of months ago. As far as the probabilistic outlook for falling into that category. Here's the plume model where most of these values do bring it down into the La Nina phase, even though there are some that keep it in neutral, so we can't rule that out yet. It may hang in neutral here for another couple of months before falling a little bit longer. But I'll let Levi talk a little bit more about that. That's just our quick little tidbit about our tropics for right now for the El Nino.
Yeah, Levi, I know a lot of what Shay was just talking about, you went into some length in your recent YouTube video, your unofficial forecast for the upcoming hurricane season. I was just hoping that maybe anybody who might have missed that, if you were in a position here to kind of bring them up to speed on what it is you're thinking we could see this summer all the way through November.
Sure. I don't know if you want me to go into all of it now or just a part of it.
Whatever you are prepared for. We've got at least an hour here, so the floor is yours.
Well, I mean, as Shay was saying, we're coming off of a strong El Nino and presumably into at least a weak La Nina state. As he showed, you know, some of the models stay a little toward neutral. It was actually interesting that some of the models, like the CFS, after it was fixed anyway, started showing a very strong La Nina for the summer, -1.5 or something like that, which is in the upper end of the strong La Ninas that we've seen historically. But then the European model came out and showed a little bit of a rebound during the later summer back toward kind of a cool neutral state, and so it was less eager to go into a strong Nina, and now the CFS is kind of coming up a little bit as well. So that wouldn't be so unheard of because we have a positive PDO in the Pacific. That's a warm ring of water around the coast of North America. And normally when you have that, it's pretty hard to get La Ninas at all, much less strong La Ninas. So to have a strong La Nina in the Pacific this year would be a little bit surprising. So I think the Europeans probably onto something with a weaker La Nina. So that does play some role in what's going to happen in the Atlantic. But that PDO is probably going to cause some problems. Normally when we have a La Nina and if the Atlantic is warm, that almost guarantees you an active season. Sometimes the ENSO gives us almost a no-brainer forecast for overall TC activity. Like 2010, very, very easy forecast. Coming off of the last strong El Nino we had into a strong Nina, that was a very easy hurricane season forecast to make. This year, not so much, mainly because the Pacific and the Atlantic are both in less than optimal modes for Atlantic activity. So the PDO puts warm water west of Mexico, and that's currently ongoing. The East Pacific in general has been very warm for the last couple of years, and when you have the East Pacific very warm, it ends up, if you will, competing with the Western Atlantic for convection during the summer, and you don't want that. You want sinking in the adjacent basins to the Atlantic. You want the Pacific to be shut down for the Atlantic to have ascent and a stronger Walker cell. But when the Pacific is active, even if you have the La Nina, if the PDO is positive, you still have warm water in the places where TCs can develop and tropical convection can fire during the summer. And if that's the case, then you get a competing Walker cell with what you would normally expect during a La Nina. And so that kind of induces more sinking over the Atlantic than you would normally expect during a La Nina year. And so that's one of the big issues. The other one is the Atlantic itself kind of has a negative tripole at the moment, and all that means is that instead of the main development region, the deep tropics south of latitude 20, being warm, this year they're a little bit cooler than the waters to the north of them. The whole Atlantic is pretty warm, but if you move along a longitude line from south to north, you'll see that the main development region is a little cooler, the mid-latitude Atlantic is warmer, and then the North Atlantic is actually cold this year. And that messes with the Hadley cell and makes it weaker. So you get less rising air in the tropics and less convection in the tropics, which is detrimental to the hurricane season because you're getting less favorable ascent in the regions where genesis usually occurs.
So in layman terms, these hurricanes are really just I guess a way for the universe to kind of balance itself out when it's dealing with all these irregularities in the atmosphere. If we really, I guess, just were to dumb this down a little bit, but you said something interesting there that I kind of just wanted to zero in on and not let it slip by anybody, or see if I understood it correctly. But it's almost like the two oceans kind of balance each other out a little bit. So if one is a little bit more hyperactive than the other, can we expect less activity in one if the other one is kind of overfiring?
Yeah, they often do move in pairs. The Eastern Pacific and the Atlantic do have an inverse relationship in general. So normally you won't find them both extremely quiet or active together. There are, of course, exceptions, but a rule of thumb is that if the East Pacific is active, whatever's causing that activity is usually also detrimental to the Atlantic in most cases.
Is that a little bit what we saw last season?
Yeah, and last year we had an actual El Nino out there, very warm water. Obviously the Central Pacific had a record season, and because of that record season was due to all that warm water in the tropical belt in the Pacific. And so that helps the Pacific, but when you have all that rising air in the Pacific, that creates wind shear due to the outflow from that convection toward the east, and to the east is the Caribbean and the Western Atlantic, and we had record wind shear in the Caribbean last year. That's obviously a negative for tropical development, so we had no storms in the Caribbean last year, and much of the Atlantic had higher wind shear, so that's kind of the relationship that usually ties in.
I know in your outlook you talked a little bit about the importance of looking at our current setup versus historical setups in the past that were very similar and what their outcomes were. But you were running into, and the rest of the weather community is running into, a little bit of a problem when they try to compare our current setup to some of the historical data that's out there?
Yeah, and especially since 1950, questionable data quality prior to that, but I usually look at 1950 and onward, and the last 70 years, the global ocean configuration is normally the best thing to look at for an analog season. And you can find plenty of examples of La Ninas. That's not hard. What's hard is finding a La Nina in combination with a positive PDO that we have, which is actually a near record strength positive PDO, and a negative Atlantic tripole of the configuration we have with a giant ball of warm water, warmer than normal, I should say, east of the United States, and that is not something we've really seen quite well in a historical year. Normally each year you'll find at least 5 or 6 that are pretty similar to what you have, but the configuration of the global oceans this year is very hard to find a match for.
So Levi, that brings me into the next question. You brought up a couple of points that I really love to get into, and I'm going to do a screen share here and talk about on the ocean analysis. When we look at our sea surface temperature anomalies, we see this cold surface water here, and this is the sign of El Nino receding as this cold water heads in this direction where the thermocline's lifting up here. So I'm very interested in this zone right here, which is known as the Walker circulation in the Pacific, and over here we have the Hadley cell, which actually extends over here, and then the Ferrel cell. Can you talk a little bit about the relationships between the Walker circulation, the Hadley, and the Ferrel cells in accordance to what to expect with an oncoming La Nina season?
Sure. Well, the Walker cell and the Hadley cells are both vertical circulation. So in the Pacific, like you were showing, the typical Walker cell is that the air rises near Indonesia and then sinks near South America. And that's your default. When you have an El Nino, it fights that, and sometimes you'll even get the most rising motion east of the dateline, near south of Hawaii in the Central Pacific, and then even sinking over Indonesia, certainly relative to normal. And then when we get a La Nina, it enhances the regular Walker circulation, so you get anomalous sinking in the eastern Pacific. That goes hand in hand with what you could call the Atlantic Walker cell. There isn't only one, although we normally think of the Pacific Walker cell. There are, there can be a couple. If you have a lot of sinking on the eastern side of the Pacific Walker cell, you naturally tend to get more ascent in the ascending branch of the Atlantic Walker cell, where the warm tropical water is between South America and Africa. So a La Nina enhances that, and that's in addition to the reduction in vertical wind shear that you normally see. With the La Nina, the Walker cell is just one more favorable feature that it adds to the equation, where you can get more rising air over the Atlantic than you would normally see if you had, say, a neutral ENSO. The Hadley cell is kind of like the Walker cell is. It's a vertical circulation, but instead it runs north to south, not east to west. So that means rising air in the tropics where it's warm and moist, and then it sinks in the mid-latitudes near the subtropical jet. And why that matters is that that can also be modulated by the ocean. So in the Atlantic, as we were seeing, the warmest water relative to normal is in the mid-latitudes, 30, 40 latitude north. And that's bad for the tropical belt if in the summer most of your convection is being focused more toward the north. You have a weaker Hadley cell because you have more rising air where you would normally expect sinking in the mid-latitudes. So then you get less ascent in the tropics, which is where you want the ascent if you want tropical development. You want rising air and thunderstorms in the tropics. So if your Hadley cell is weaker due to this ocean configuration, it's usually bad for the tropics.
Levi, I'm curious, with all that in mind, do you have a number of storms that you're expecting to see this season?
The number of storms as a metric even itself is very fuzzy, not to mention hard to predict, but it also doesn't mean as much as some people might think. But I would put the season's character overall to be near normal, is my feeling. There are some counterbalancing factors. The La Nina is good. The Pacific and Atlantic ocean configurations are not so good, and I think overall we'll see kind of a balance of those things this year. So as far as number of storms, I would say around normal, but we've had some weird years of late. For example, 2012 had something like 19 storms, and obviously Hurricane Sandy, but as a season overall, 2012 was not necessarily what you would term hyperactive. Just as an example, 2013 was kind of the same way. A lot of weak storms, not so many hurricanes and major hurricanes. So the number of storms can sometimes be a bit deceiving. You can have few storms, but almost all of them are major hurricanes, like some years. You can have a ton of storms and only a couple are hurricanes. So it's hard to put, an actual number on things, but I gave 10 to 13 in my preseason outlook, which is near normal. 11 or 12 is about the long-term running average.
And do you find in your experience the public really gets locked onto those numbers regardless of the actual number of potential landfalls that a season might have and where the actual devastation and impact comes in?
Oh, for sure. And, it's the only numbers that they see. And NOAA, who will give their official outlook on May 27th, does not give landfall probabilities or track distributions or anything like that, and we may be nearing the era where they may have the tools to begin thinking about those kind of outlooks, but right now all they give publicly are the season total storm numbers and the ACE value, which is just a measure of overall activity. And that's what the public sees, so it's what the public knows. And unfortunately, it doesn't say a lot about how many hits the United States will get. I mean, the number of storms in the Atlantic only explains about 25% of the changes from year to year in how many storms hit land in the United States. That other 75% of the variability is from other things. So you may have a weak season, only 6 storms, but maybe 4 of them form in the Gulf and hit land. You may have a hyperactive season like 2010, 19 storms, but very few make it to the western side of the basin and hit the United States. So it can be a little bit deceptive. It's kind of a little bit of a red herring, because regardless of how many storms form in the Atlantic, it's how many hit land that obviously matter most to people.
And I know in your video, and Shay's kind of got the overall landscape from your video up at the moment, there was a moment also where you talk about we could see a little activity more directly off the coast of Florida. Is that correct? Maybe something that actually maybe will start there, not be as strong, but see a little activity there off that coast?
Yeah, in a very general sense. I tried to make this as broad brush as possible because no one can know whether an individual state will be at enhanced risk. Florida, who knows? And Florida's been lucky for 10 years. That lucky streak won't continue forever. But in general, in a year like this, we're probably expecting the main development region west of Africa to be less favorable than usual. So below normal activity may be possible there, but then farther west, we do have a lot of warm water lying around. So even though the warm water is in what you would consider the wrong place to have a hyperactive season, it is close to the coast, and so that increases the worry for what we term homegrown developments, storms that can form from baroclinic influences like fronts dropping down, like Shay mentioned earlier, off the Carolina coast or something. Things can spin up at the tails of those fronts. You can get upper level lows that spin down into the tropics and fester for a while. And you can get developments that occur close to land and then very quickly track into a landmass because they're forming close to land to begin with. So we don't have all those long track hurricanes that come off Africa and travel hundreds of miles before making it to the shore. They may form very close to the shore, and that poses a problem for preparedness because you get less warning time. And if they're forming on top of you, there's more uncertainty. So there's always that kind of a worry, even a year like this where we might not expect hyperactivity.
Levi, I've got a question for you. As far as when you talk about below normal activity in this area, do you ever factor in the Saharan dust levels that are going to be coming off of the African coast, and even some of the patterns that go along northern Africa or even up into Europe or the Mediterranean? Do you ever factor any of those upper air, mid-level air patterns into that?
Well, for sure, and I didn't look so much at Saharan dust this year, but what I did look at is the fact that we're likely to continue in the positive NAO regime, which means a strong Azores high in the eastern Atlantic. That's largely because of the SST distribution again, where we have all that cold water south of Greenland right now. So if you have a strong Azores high, that brings a lot of dry, stable air down from near Spain and Portugal along the west coast of Africa and kind of drains dry air into the tropical belt. And we had that problem last year a lot, and that is probably going to continue this year, I would guess, because of this positive NAO that we're dealing with, and we had for much of the winter, and we'll probably have for the summer as well if things continue the way they're going. And so that, even more than the Saharan air layer, causes big problems because it's a really deep layer of dry, stable air. Saharan dust is harder to get a handle on. I know the last couple of years have been pretty wet in the Sahel. Normally that implies that there's more soil moisture available early in the year, which means perhaps less dust available to be kicked up by tropical waves as they come west as we get deeper into the summer. But it is hard to tell exactly what the dust levels will be months in advance. That's usually difficult to ascertain.
Gotcha. So you're saying that you're thinking the Bermuda Azores high is going to be further removed to the east versus a stronger Bermuda high in this area.
Perhaps. The Bermuda high is more difficult. The Azores high in general, whether it extends over Bermuda and forms that Azores-Bermuda connection or not, is perhaps another question. But at least having stronger high pressure, west of Portugal near the Azores Islands themselves is probably a good bet with the pattern that we have.
About halfway through the show, we'll remind folks that they can reach out to us on social media if they have a question, including @Carolina weather group, Carolina WX group on Twitter, and we will relay your questions here on the live show. But let's go out to some of our other panelists. I believe Kit has a question. And I believe Kit is also still muted.
Thank you there, James. Yeah, so this one's slightly off topic from the what we've been talking about in this year to come, and it's more focused on just some quirks of what happened in the past. I remember the 2005 year was very active, but just before that, we had the 2004 Hurricane Katrina, I think. Yeah, so what was it that happened with that, and would that be something that we could ever expect to happen again maybe this year, coming off of that El Nino and that Walker circulation flipping?
Okay, so for those who don't know, Hurricane Katrina was a rare tropical cyclone that formed off of Brazil in the South Atlantic. This was an interesting event. I believe that to this day, some of the research community still disagree on whether it even, we don't think it was. And one of the reasons there's such doubt is because we just really don't see storms in the South Atlantic like that. That was a very, very unique event. That was a long time ago. I'm not currently remembering much of the details of the pattern that led to the genesis of that event, but I do remember seeing it and tracking it. It was quite a day. I do remember that. I believe there was much warmer than normal water, ocean SSTs east of Brazil during that year, and we had something like that near the tail end of their tropical season this year. In fact, it was aiding drought, I believe, over some of the Brazilian agricultural regions during the tail end of this winter because of all the warm water off the coast, but we didn't get any tropical events out of it like we did in '04. It's something that you could certainly see again. I mean, if it's happened before, it'll happen again someday. It's just a rare event because conditions don't normally intersect in the South Atlantic over a large area, and there aren't very many tropical-borne disturbances. Normally you have to rely on what our equivalent of homegrown mischief would be, with fronts dropping down from the polar region and kind of festering over the warm water. I believe that's normally how they get most of their tropical systems.
Okay. Well, Levi, talk a little bit about the Gulf of Mexico and what to expect over that area. I'm going to do. I know I'm full of all these screen shares tonight, but I want to show the current sea surface temperatures that I pull from the Sport SST from NASA, and you can see the loop current really starting to warm things up where that area blew up yesterday, and then also the Bay of Campeche is warming up pretty quick as well. Everything's starting to come into place for the Gulf. Talk about what your thoughts are for the rather inactive Gulf for the last few years and what you think this year might hold.
Sure. Well, the Gulf, again, a very interesting place, very distinct in some senses from the Caribbean and east of Florida in terms of genesis regions, and there's often, kind of a seesaw between those three regions as to where you get most of the storms actually forming and tracking. The Gulf can obviously get storms that form outside of it and then track into it, like 2005 had a lot of those, 2008 had a lot of those, but you can also have years where a lot of storms form in the Gulf itself. 1985, one of the tentative analogs for this year, had a few of those, actually a lot of storms near and east of Florida. The loop current itself doesn't determine very much. It's simply there as a feature for storms like Hurricane Katrina when they move over it. Strong evidence that they get very enhanced by that deeper layer of warm water in the central Gulf. So it's kind of a by chance thing. If it's there and if it's strong and if there's a hurricane that happens to pass over it during this year, then it could take advantage. Gulf SSTs in general, though, don't really correlate very well with activity. Just because the Gulf is hot does not necessarily mean you'll have storms in it. In fact, often the hottest Gulf years are especially because you have strong high pressure over the Gulf shutting down everything. There's no clouds, so the sun warms up the water a lot, but because of that high pressure and sinking air, there's no chance for TC genesis. So the sea surface temperature itself shouldn't necessarily be a concern, but the Gulf is always going to be hot enough for major hurricanes. No matter what, any year it's going to be 30 Celsius out there, so that's never a problem. If it gets hotter than that, it's a concern if a major hurricane does come through, but that temperature in and of itself doesn't tell you very much. But this year, I think we might have a better chance of seeing some activity that we haven't seen in the last couple of years there, because we do have the La Nina in the Pacific, and so there is going to be some colder water, higher pressure off South America. Normally that intensifies the moist flow across Central America into the Western Caribbean. You get a little bit of a stronger Central American monsoon, and you have a better chance for trade winds to be slower in the Western Caribbean, which means less wind shear, perhaps some more lower level convergence for that reason. If the trade winds are slower, that means air is piling up from east to west as the air nears Central America. That allows convection to flare, and that flow is normally directed into the Gulf from that location. So tropical waves that enter the Western Caribbean can move into the Gulf or even track north of the Caribbean and get into the Gulf from the east. And we could have a better chance for genesis if we don't have suppressive high pressure. That is one of the things about a positive PDO, is that you tend not to have a very suppressive summer ridge over Texas as often. Negative PDO, such as what we had back in 2010 and such, gives you a very strong Texas ridge, and sometimes that puts a lid, if you will, on the Gulf, prevents storms from forming very far north. If they do form, it's usually buried in the Bay of Campeche, and it's a problem for Mexico, not so much the United States. In a year like this, we might have a better chance of having a less suppressive ridge over the southern states. And if you lift that ridge far enough north, you allow room underneath of that ridge, if you will, for tropical waves to fester and fronts and all that to come down and sit over the warm water and have a better chance to take advantage of an unstable environment and develop.
Sure, yeah, we see quite some time, or quite a few times throughout the summer, we get the northeast Gulf highs that develop from heat fluxing, and then some of the western Gulf highs. So certainly understand about that with the dry air that encompasses that entire area from time to time. So back to you, James. Any questions from you?
You mentioned Texas a minute ago, and we've seen a lot of flooding there of late, and I'm wondering, as somebody who pays a lot of attention to the tropics, is there one hazard more than any other that really catches your eye when you're tracking these things and monitoring their potential impact?
From an individual storm standpoint, water is the problem. Most people may not realize that wind only accounts for about, I believe, a quarter of all hurricane-related deaths. And so from a storm's point of view, it's the storm surge, and it's the inland flooding, it's the rainfall. That is the big problem. And a recent study actually just came out about a year ago detailing all the stats on that. I'm struggling to remember the author's name. There are a bunch of people involved from the NHC and such. But they have a great pie chart and statistical overview. 3/4 of hurricane-related deaths are water-related. So that's the big issue, and it reinforces the point that even if you're talking about a tropical depression, a tropical storm in the Gulf, some people might remember Tropical Storm Allison in Texas about a decade ago. And that was only a tropical storm, but it was one of the worst flooding events in that region in their history. And that can be a huge concern. We're tracking a tropical storm in the Indian Ocean right now, and it's doing a lot of damage even though it's weak because there's just so much water falling. So really, it's the rainfall. So even the weak storms can get you really bad. It's not always, wind is not the biggest issue normally.
What were they forecast, 20 to 24 inches there?
It's something crazy. It's ridiculous over there.
That's the India storm you guys are talking about?
Yeah, the India storm. Yeah, rain is also a big issue, not only along the Gulf Coast, but also for those of us in the Carolinas and also up into Virginia, because when I first moved here a year and a half ago, I was well aware of Hurricane Camille. I was well aware of what it did along the Gulf Coast, but I was not necessarily aware of what it did up here in Central Virginia. The county just off to our south, Nelson County, they picked up 27 inches of rain in a 24-hour period because the remnants of Hurricane Camille came in and interacted with the stalled frontal boundary, and it just squeezed out all the moisture right over the top of them, killed 153 people, some of which were never found. So it's not just when kind of relaying to the public, hey, yeah, this storm is going to be bad, it's going to have winds of 120 miles per hour. You also have to remember of the water not only close to the coastline, but also well inland, because, I mean, we're, 1,000+ miles from Louisiana and Mississippi where Camille hit, and we had a crazy amount of rain. Hurricane Juan back in 1985 also did similar things here, not necessarily to that extreme, 20+ inches, but it still dumped crazy amount of rain and flooding all the way up here into Virginia.
Well, speaking of prevention and safety and awareness, we look at forecasting. We start to look at computer models quite a bit, and we look at them pretty far out from time to time, and sometimes get a little carried away with what we see. But Levi, tell us a little bit about some of the models that you favor for at least a 48 to 72 hour period out, because anything after that would normally you start to become very erroneous in models. So give us an idea of which models you kind of look at, or what sort of agreement you look for.
Sure. Well, it's a really interesting era. The last five, even 5 years, and especially 10 years, have changed a lot. We have hurricane-centered models like the HWRF and the GFDL, which have been around for about 5 years, and they're high resolution, centered on the storm. That's something that global models have not been able to give us, is an accurate depiction of a TC and how strong it is in the model. For example, the GFS forecast for Katrina in '05 had a storm that was far too weak and therefore had an incorrect track. Today, that would not be a problem for the GFS. Because the GFS is such high resolution, we're now down to 13-kilometer grid lengths in global models, and the Europeans are down to 9. And so the global models are now providing value that even 5 years ago we weren't necessarily getting from them. And so I find myself looking at global models even more sometimes than hurricane models, like the HWRF. The HWRF, though, has been a great tool. It's certainly one that I look at even more so now. A few years ago, it really wasn't so good. Lately, it's been better. Last year, it did better with Danny in some respects than the GFS, which was one of the lone hurricanes we had out in the middle of the Atlantic. And I'll look for it again this year. It keeps getting upgrades to its ocean coupling and things like that. But as far as some of the other models go, the European's always a go-to in many respects. It does have its own biases, but they are also well known. And so if you see the European forecasting hurricane development out in the main development region, that means a lot more than seeing it from the GFS or the Canadian models, because they tend to be a little bit overzealous. So to have kind of the calm adult in the room, more skeptical model, the European, telling you, hey, it's not such a great chance for Genesis, you normally latch onto that as kind of a forecaster, and you weigh those together. Once you use the models long enough, they all become valuable to some extent, because when their biases become consistent over time, you know that. And so you can use that to your advantage. You know what the weaknesses of the models are, and so even though some of them, like the Canadian, may be very hyper, you can get value from them because you know how consistently they make those biases. So they are all useful, but I would say the HWRF and European model are probably two of the most useful, with the GFS close behind.
Any particular times you favor? The 12 a.m., the 12 a.m. and the 12 midnight, for instance?
No, I mean, there's a lot of superstition about 0 and 12Z versus 6 and 18Z. Especially now with the GFS going into 4D VAR assimilation, that means it has a time component in how it ingests data. That will even alleviate that problem even farther, and it really hasn't been an issue, because the model will use data from the previous cycle and a forecast as a first guess if it has to, if it doesn't have SONS, let's say 6Z or 18Z. And over the ocean, we don't have SONS anyway, so it's mostly satellite data no matter what cycle you're running. So really, there's no tangible evidence that I've been shown for not trusting the 6 or the 18Z. Sometimes you see some very weird oscillations where only the 6 and 18 show Genesis or don't, and then the 0 and 12 for a couple of days in a row are the only runs that show it. It's hard to say whether that actually means anything or whether it's a coincidence, but the GFS is often kind of fickle. It has that reputation in the tropics anyway.
Yeah, I'm looking forward to seeing the Panasonics once they get, when they get theirs up and running, because they're going to be using SONS or readings from airplanes, all thousands of airplanes a day. So that should be interesting.
That actually brings me a
nice.
perfect segue to my next question. Is there something coming out that you're really looking forward to? Technology.
Coming out. I mean, we're getting a lot of model upgrades the last couple of years. The GFS just got upgraded. The European just got upgraded. They are untested in the tropics. I'm really looking forward to see how they do this year. In some sense, it's kind of like, well, now I don't know my model very well anymore. You get to know it for so long, and then it gets upgraded, and you don't know what to expect from it. But we'll see how that changes. I'm really looking forward to some of the upgrades I saw. I was recently in Puerto Rico for a tropical meteorology conference a couple weeks ago, and I saw a lot of talks about advances that they're making. They're going to have a brand new global model developed here in the U.S. During the next 5 years, and that's going to replace the GFS and have dynamic nesting, so you can have high resolution where storms are and then low resolution where you don't need it. All sorts of cool stuff like that. The HWRF will continue to get upgrades. I want to see ocean coupling in hurricane models and global models. That's a big deal. It's hard to do, but it would improve our forecast substantially. That's going to be really cool. And then, probably my favorite upcoming upgrade, though, is GOES-R.
Yes, I was going to say, don't forget that.
Because I was stuck in the modeling realm, but GOES-R has got to be our favorite toy coming up in the next couple of years. We're going to have satellite images every 5 minutes, perhaps even more frequent than that during storm days. We can again 1 minute imagery for supercells over the U.S. and perhaps even for hurricanes. I'm not sure about that yet, but higher resolution visible imagery, and you can see a preview of that if you look at the Himawari 8 images from the Japanese satellite in the West Pacific, and it's gorgeous. You can get true color imagery of the Earth. It's some of the most beautiful, astounding stuff I've ever seen. So I really hope we get that up and running soon.
I keep wishing that they would come out with some new METOP A and B scatterometer upgrades for what they have. Because I can't even imagine how much data is in each of these swaths that go across on each ascending and descending passes. It's probably an immense amount of data. But it'd be nice to be able to cover an entire ocean during an event.
Yeah, quick scat replacement would be something we very much desire. Yeah, because ASCAT right now is not cutting it. It misses too often. The swaths are too thin, so we really need a replacement for that.
Peter, is this show too bright for you?
I forgot what it was like to wear sunglasses, so I thought I'd wear them tonight. No, I'm just kidding. My eyes are a little bothering me tonight.
You wear sunglasses at night. That's okay. That's what all the good 80s rockers do.
That's right.
David, as our broadcast meteorologist in-house tonight, those high-resolution models, I imagine they would make your life as a public presenter better.
Oh, yeah. I mean, one would think, but they also have to be able to capture the synoptic scale stuff going on as well, and what eventually drives the hurricane and how strong it gets. And as Levi, it's a question I have for you: is there anything, or any one thing, or any couple of things that you look at that could give you an idea as to the intensity of hurricanes? I know that's a very not well modeled thing, at least as of late. I was wondering if there's any new advancements in the intensity forecasting arena.
Yeah, that's a tough one. We're definitely many years behind in intensity forecasting compared to track. We have not improved nearly as much in intensity forecasting, though there is some evidence during the last 5 years we've started to get better all of a sudden. Whether that's a spurious trend or not kind of remains to be seen. Need a few more years looking at that to make sure, but it does seem to be some positive trends that we've gotten, and a lot of that seems to be due to some of the projects we've gotten out of HFIP, which include the HWRF, some of the ensembling that we've done, and these projects to get hurricane models working in a positive way. That seems to have been helping a lot. And as I said, the global models getting to the point where they can start resolving TCs, has really helped as well. Having their guidance where it's not a nested model, it's an actual full global model, so it really has internal consistency, and to have those forecasting TCs explicitly has really been a big help. Those seem to be the big advancements. Usually hurricane forecasting tends to follow weather model skill. Humans are, we kind of have a ceiling on how good we can get. Nowcasting, sometimes we can be a little bit better. Maybe some long-range tweaking of the biases in the models. But by and large, our skill comes from interpreting and bias correcting weather models and the skill that they already have. So those seem to be the primary advancements that we've had in getting some improvement recently in intensity forecasting.
I was looking for sunglasses, but apparently I don't have any. I'm not cool enough. We're coming up to the top of the hour here, and don't want to end the show with that. Oh, yes.
I do have one last little thing to add on to. We've had difficulty with storm intensity prediction. How well are we doing with storm motion? Because when we have the motion of the storm generally is going we'll say northwest, but the eye wall itself has that, I think it's called trochoidal motion, that it bounces around within sort of a row of motion. How well are we doing to predict that?
In the short term, you can get those wobbles that you're talking about, trochoidal oscillations, that normally occurs when you have more than one eye wall. you saw that in Hurricane Wilma a lot back in '05 in the Caribbean. That's the prime example of trochoidal oscillations. If you look up a loop of that, you'll see what Kit's talking about. But in terms of now casting the motion, that's pretty hard. You get frictional effects near the coastline when storms are approaching landfall. That may have played some role during Hurricane Charlie in '04, which some may remember was forecast to move closer to Tampa Bay, ended up moving in closer to Fort Myers. Little shifts just before landfall, and this is why the NHC always says don't focus so much on the exact track forecast, because the eye may be a small area most of the time, and so it only impacts, maybe a 100-mile wide area with the worst winds. But that little track can get nudged, 50 miles just before landfall in a very short amount of time due to all sorts of, convective interactions with the land, convective dynamics in the eye wall that you're just not going to be able to see. So from a nowcasting point of view, that's always going to be a problem with the little shifts right before landfall. But in terms of longer range track forecasting, we've been getting pretty good, even to the point that the Hurricane Center is now thinking about 7-day forecasts instead of just 5 coming up soon now. And so that's going to become a thing as our skill gets better in the longer range. And again, mostly thanks to dynamical modeling, has allowed us to know, where the Rossby waves are better, 5, 6, 7 days in advance, so we know when storms are recurving, where they recurve, how they're going to track, and the fact that the models represent them better also influences the track. I brought up the GFS Katrina example from '05, where the GFS had a weak storm but also a very broad storm, and so models back in those days, you would get them recurving too quick because the storm was weak but it was large in the model, so it was getting picked up by troughs easier. These days, the GFS can simulate a reasonably small, compact, strong TC that will more correctly feel the influence of troughs to its north. And so today's GFS probably would have forecast Katrina much, much better. All of those things have given us a lot of skill in longer range track forecasting.
Oh, I did not know that about the NHC. So you're talking about where they give a certain percentage in 48 hours and a certain percentage in the next 5 days. They're talking about going to 7 days out.
Oh, I don't know about Genesis, but at least for the forecast cone, beyond 5 days may come in a few years.
Gotcha. Now, that was going to be another question to segue into, now that you brought it up, is the cone of uncertainty is going to be shrinking in time, and as they become more exact. But do you think it would change this year as compared to last year just because of the new upgrade, or do you think that they're going to stick with this 5-day without trying to keep that cone of uncertainty thin? You know what I mean? Like how it sort of goes out to a certain point, and then it covers a much larger area, and there's a certain percentage for that. I forget how it goes.
Yeah, I think they update it yearly. It's based on the 5-year running mean NHC forecast track error, and the cone is designed, I believe, such that the hurricane falls within the cone 70% of the time, based on their forecast errors during the last 5 years. And so I do believe they update that yearly. Eric Blake tweeted a few weeks ago a great example of Katrina versus today, 10 years later, 12 years later. The cone has gotten much smaller since that time because the 5-year running mean error has gotten smaller. So we're forecasting better, so the cone is much thinner. Obviously, that calls into question, what's the visual interpretation of the cone in the public's eye? What do they think when they see the cone? What do they think when they see a thinner cone? In the limit of perfect forecasting, your cone would just be a line if you had a perfect knowledge of where the storm was moving. How does the public interpret that? So those are some of the new debates going forward, is how do we interpret that cone?
I think I may have finally just found that graphic we were talking about. Pop it up here real fast. I believe this is the correct graphic for 2005 versus 2015 modeling of Hurricane Katrina. And you can see, just like you were describing, the cone kind of got a little bit smaller. I was looking for a bigger version, but that's what I've just stumbled across on Google. Kit, did you have another question?
I was just gonna say, like what Levi was saying there at the end, with the perfect model forecasting of a line, you're gonna get people who think, oh, if I'm 5 miles south of this line, it's not gonna affect me. When in fact the storm can be a few tens of miles wide, even 100 miles wide, and it impact a lot more people than just who lies right underneath that line.
Mm-hmm.
Until they look at a bad hair day on the spaghetti plot.
Right.
Levi, you're a guy of data, and you've been running a website since, did I read 2002? Is that correct?
I've been blogging since '05. Website has been up since 2012.
Oh, 2012. Okay, so but you've been covering these for quite some time now. I'm curious, what's the most visited part of your site? What do people really gravitate to when they're coming to Tropical Tidbits to look at all this data?
I think it's safe to say the models page. That's the big one. People like eye candy, and models give them eye candy, and it's a wonderful forecast. Models are a wonderful tool, as we've been discussing them a lot here, and that seems to be the most ubiquitous feature. No matter what time of year, models can be used to forecast your local weather, tropical weather, severe weather, anything. They're there. They're a forecaster's friend, and one of the best tools in the toolkit. So that seems to be what people like to use.
And do you find people are consuming this year-round, regardless of whether or not we're in tropical season?
Yeah, it's funny. Over time, I've had to add winter products because people are there in the winter. Well, there's no hurricanes to look at. What do I do now? Oh, right, there's nor'easters and blizzards and all sorts of things. So over time, I've kind of expanded beyond just the tropical data set. And so now even the default plot on the GFS now actually has multiple precip types on it, because that's how often it's used.
We certainly appreciate it.
Oh yeah.
Yeah,
Absolutely.
actually, I think
love
David
the
was the one
4
who
kilometer NAM hourly, by the way, for the first 24 hours or whatever. Oh my goodness, phenomenal.
I finally got around to that.
Are there any big things coming down your pipeline that you can share with us?
The only real thing I can think of right now is GFS now has hourly output through 5 days. I'm thinking for at least the Atlantic this summer, I'll try to pop out a few fields that come out every hour, so we can see even quicker where the GFS is sending the storms this year out to day 5. So look forward to that maybe.
And running a website, especially with this much data and this much traffic, isn't cheap. How do you keep up with that?
I didn't for a very long time, and then last year I added ads to the website, and the website largely pays for itself now, which is a great blessing. I wouldn't be able to do it as a student without the ad revenue, so that's how it sustains itself now.
All right, well, fabulous. You got a lot of great data on there, as we just were talking about in tropical season and not in tropical season. I think David Reese was the one who first introduced me to your site a couple years ago, and I don't think we were tracking tropics at the time. I think David was in the TV Weather Center looking at something localized. So I'm glad to hear you have at least broken even, if not a little bit more, with that ad revenue there. As we start to wrap things up, can you let folks know where they can find you on social media?
Sure. I'm most active on Twitter at Tropical Tidbits. I'm always tweeting about stuff, and you can contact me through my email, which is on my website, tropicaltidbits.com as well.
You've been a guest of the show before, so I think you may know how we typically wrap things up, but the question generally is, we have a lot of teachers and a lot of students who watch the show who are looking to get into this field for the first time. Do you have any advice to them on what they can do to really expand their knowledge base?
Well, I would say for teachers, I'm not sure I could give very good advice, but for students, I would say if you're coming into a career in meteorology, it's so vast, there's so many options for you, but if you're looking to do research, to be a forecaster, to get hired somewhere, currently, programming is a big deal. Learn how to program if it's applicable to what you're doing. If you're looking to do research, don't wait until someone makes you take a class for it. Learn how to program sooner than later. Spend effort outside of your school time, actually getting to know your field better. If it's tracking storms, if it's something fun, just spend some time becoming a better meteorologist if that's what you're looking to become. It's definitely worth spending extra time.
That's very interesting that you say programming. Anything in particular? I'm just as curious. Are you talking about coding and building a website and being able to ingest all that data?
Well, like I said, there's so many facets you could go into. Speaking just from, say, if you want to go into research, programming is a big deal. Learning how to work with data, learning what data even is, what are the formats, how do you work with it, how do you do math on it, things like that. Knowing a programming language is extremely helpful, but it can also help you for visualizing your data, understanding your data, such as plotting it, which is obviously something I do. Plotting the data requires programming knowledge, and it really opens so many doors for you. And knowing how to understand what you're seeing, how you get what you're seeing, and what kind of, what are the pros and cons of the data, what's the uncertainties in the data, all of these things become so much clearer when you end up doing some hands-on with it. In many ways, programming is a hands-on experience, and many people learn best that way.
And to add on to that of talking about programming, I had to take a programming class for my department, and we're going to be taking another one next spring. I would have loved to have learned programming in high school rather than in a college environment.
It's much less stressful if you learn it early, that's for sure.
Well, Levi, thank you for your time again and for coming on. For our viewers, this is just one of many tropical and hurricane-related shows we will be having in the coming weeks, so stay tuned for more on those. If you are looking to catch up on any of our past shows, you of course can do that on social media, especially on YouTube, and you can also download our podcasts. Thanks so much for joining us this week. We hope you have a great week, and we'll see you right back here next week.